Hello everyone, good morning. Here I am going to take Dijkstra's shortest path algorithm. Okay, so the main topic is single source shortest path algorithm, and this algorithm is used for solving Dijkstra's shortest path algorithm. Okay, so that means that this algorithm is of this Dijkstra's shortest path algorithm is of a single source shortest path problem. If a weighted graph is given, we have to find the path from a starting vertex to all other vertices present. So you can see here, this is a weighted graph, and this is a weighted graph, isn't it? And we have to find the path from a starting vertex to all the vertices present here. Let us say I am selecting vertex 1 as a starting vertex. Then I have to find all the shortest path from 1 to all vertices. That means I have to find the shortest path from the vertex 1 to 2, then from 1 to 3, then 1 to 4, 1 to 5, and then 1 to 6. Okay, maybe it is a directed path or via other vertices. I can select any vertex as the source vertex. It is not necessary that I will be selecting only one as the source vertex. I can start the process by selecting any vertex as the source vertex. That means I can select 5 as the source vertex and then start the process to find the shortest path from 5 to 6, then 5 to 4, then 5 to 3, then 5 to 2, then 5 to 1. Okay. And as we have to find the shortest path, it is a minimization problem. And a minimization problem is an optimization problem. So, optimization problem can be solved by using greedy method. You know that. And you know what is a greedy method? Greedy method says that a problem should be solved in stages by taking one step at a time and considering one input at a time to get an optimal solution. In greedy method, we have a predefined procedure and we follow those procedures to get an optimal solution. Okay, so Dijkstra's algorithm will give as an optimal solution, that is a minimum shortest path. In this video, I will show how Dijkstra's algorithm works to find the single source shortest path for us. It will work on a directed graph as well as on an undirected graph. And also, at the end of the video, I will show you the drawback of Dijkstra's algorithm. So let us see the approach of Dijkstra's algorithm. For that, I will show you the basic thing followed by Dijkstra. For that, first of all, I will show a small example. Okay, I will show a small example. Suppose this is our graph. Okay, a small graph. It is a small graph and we have this directed graph with us with 3 vertices only. Okay, and the weight assigned to on each edge is this one. For 1 to 2 it is 2, 2 to 3 it is 4. Okay, suppose I am taking the source vertex as 1. This is our source vertex. Now what I have to do? I have to find the shortest path from 1 to 2 as well as from 1 to 3. From this, we will understand what is the approach of Dijkstra. If I say 1 is the starting vertex and I have to find shortest path to 2 as well as to 3. When you see this graph, you can find there is a direct path to 2. You can find that you have a direct path from 1 to 2. So its cost is 2. So its cost is 2. That means to reach vertex 2, you have to spend 2 cost of 2. Okay. Now, but there is no direct path from 1 to 3. So first of all, what is that? You don't have a direct path, so the cost of 3 will be infinity. Okay, that means you don't have a cost from you don't have a direct path from 1 to 3. So its cost is infinity. When we follow Dijkstra algorithm, we have to select the shortest path first. Now, out of these two, 2 and infinity, which one is the shortest path? Which one is the shortest value? This 2 is the shortest value. Okay, so I have to select vertex 2 I have to select vertex 2 as the shortest path vertex. Okay, so I am selecting vertex 2 as the shortest path. Okay, just a second. So I have to select vertex 2 as the shortest path. So I am selecting vertex 2. Clear? And Dijkstra says that when you finish the selection of the shortest path, then check whether you have any shortest path to other vertices via that selected vertex. Now what I have to do? I have to check whether I have a shortest path to some other vertices from 2 or not. So yes, we can say that here if we have a shortest path from 2 to 3, isn't it? We have a directed path from 2 to 3 and that is vertex 3, and the cost of vertex 3 will be, what will be the cost? Initially from 1 it was infinity, but from vertex 2 the cost will be cost of 2 plus distance to the distance from 2 to 3, that is 2 plus 4. So I will be rewriting this cost as 6. 2 plus 4, 2 plus 4 equal to 6. Okay. Now we can say that we have path from 1 to 2 of distance 2, and we have a path from 1 to 3 of distance 6 via 2. Okay, this path from 1 to 3 is not a directed path, but there is a path. Okay, so what we have to check, we don't have to find the directed path, shortest path which includes directed path only. We have to find only the shortest path. Maybe that path will be a directed path or it may be an undirected, means it may be via some other path. Okay. So what happens when you find a value? That means what, you initially you didn't have the path from 1 to 3. Now the next time after getting the shortest path as vertex 2, you you recalculated the cost of 3 and you relaxed the cost of 3 from infinity to 6. So we have to relax the highest value vertexes, relaxation. Okay, that means if this is a formula, you just write down, if d of u plus c of u comma v is less than d of v, then what you have to do? You have to relax the value of d of v equal to d of u plus c of u comma v. So that is what you done here. So here, if suppose your u is this one, your u is this one, your u is this one, okay, and your v is this one. You just check. If d of u, what is d of u? The cost of u. Okay, this is 2. The cost of u is 2. So you have to write here 2. And c of u comma v. So it is the weight given on that edge u comma v. U is your 2 and v is your 3. Okay, so 2 comma 3. So that is the weight. So 2 plus 4. So this is all total. What is the weight given? 4. Okay, so 2 plus 4. What is it? It is 6. So 6 is, and what is the d of v? Cost of v initially it was infinity. So you have to check whether 6 is less than infinity. If the condition is true, then you have to relax the cost of v by updating the smallest value on v. Okay, so what was the smallest value here? It was 4. Sorry, it was a 2 plus 4 and that is 6. Okay, so you have relaxed the value of 3 by 6. So this way you got the shortest cost for your vertex 3. Clear? So you have to remember this formula for calculating the shortest path from one vertex to all other vertices. Now I will be erasing these things. And I will solve for the so similarly I am erasing all this. Sorry. Okay, I will rewrite that later. Clear. Now I am going to calculate this one. Okay, I am going to calculate this one. For this figure, I am going to calculate the single source shortest path. So let us start. So here what I am going to do, I am going to take this one as the source vertex. Okay, and now what you have to do here, you have to find the shortest path from 1 to 2, then 1 to 3, then 1 to 4, 1 to 5, 1 to 6. Okay, now first you check whether you have a direct path, you have a direct path to 2. Yes, you have a direct path to 2. So the cost of 1 is 0 only. Okay. Now you have a direct path to 2. So what will be the cost of this 2? This will be 2. Vertex 2, the cost of 2 is 2. That is d of cost of 2 means d of u. Here u is 2. So d of 2 is 2. Okay. Now you have another directed path to 3. And what will be the cost of 3? It is 4. Okay. So to reach vertex 3, you need cost of 4. Okay. Now you have to find the path from 1 to 4. So as of now, you don't have any directed path. So it will be, initially you have to put infinity. For 1 to 5 also you have to put infinity. You don't have direct path from 1 to 6. Again, you have to put infinity. Okay. Now you have to follow that relaxation formula, and Dijkstra say that after initializing all the vertices with the cost, you have to check the vertex with smallest cost. So now you will find the vertex which is having the smallest cost. Here you have selected one. You started your process from one. So you have selected it. Okay, so I will write like this. Selected I will indicate by this green. So one vertex, the vertex one you already selected. Now you have, so you don't have to consider 0. Okay. Now you have to consider, you have to select the vertex which contains the lowest cost. So you have to check whether 2, 3 vertices 2, 3, 4, 5 and 6, which is having the lowest cost. 2 is having the lowest cost, isn't it? 2 is having the lowest cost. So now what you have to do, so you are selecting 2 because it is having the lowest cost. So you are selecting 2. Now from this 2, you have to find the shortest path to 4, to 3, to 5 and 6. So here you have a directed path from 2 to 3. So let us calculate. So 2 d of u plus cu comma v. Here u is 2, v is 3. Okay. So what is the relaxation formula? You just have to write down that relaxation formula once again. Relaxation. What is that? Relaxation, that is if d of u plus c cost of u comma v is less than d of v, then what you have to do, you have to update the value of d of v, which is equals to d of u plus c of u comma v. Okay. So here right now, which is the what is the value of u? It is 2. What is the value of v? It is vertex 3. Okay. So d of u means d of 2. It is 2. And c of u comma v, that is c of 2 comma 3. It is 1. Okay. So what you have to do? You have to calculate that 2 plus 1 is less than 2 plus 1 is less than d of v. V is 3. So d of 3 is 4. So 2 plus 1 is 3. 3 is less than 4. Yes, 3 is less than 4. Then what you have to do? You have to update the value of v. So you are updating it. Okay, so you are cancelling the value of 4 and you are writing it as 3. Clear? Now here you are doing the same thing. From 2 to 4 you have a direct edge. So you are again checking 2 plus 7. That is D of U is 2 right now and V is 4. So D of U is 2. C of 2 comma 4 is 7. So 2 plus 7 is 9. 9 is less than infinity. Yes, the 9 is less than infinity. So you have to update the value of infinity by 2, 9. Okay. So now after doing this, what you have to do? Now you have to check the vertex which is having the shortest minimum cost. Okay, so you have to check 3, 4, 5 and 6. Now you have to select the vertex which is having the minimum cost. So your vertex 3 is having the minimum cost now. So you are selecting 3 because 3 is having the minimum cost. Okay. Now from 3 you have to find the minimum cost path to other vertices. So you have a direct path from 3 to 5 and it is having the cost 3. The cost on the edge is 3. Okay. So again using this formula here, what is U? U is 3. What is V? It is 5. So D of U is 3 and C of U comma 5, that is C of 3 comma 5 is 3. So 3 plus 3 is 6. 6 is less than infinity. So you have to update the value of infinity by 6. Clear? Now after that what happens? You have to select that vertex that is having the minimum cost. Now you have to focus on vertices 4, 5 and 6. So you will find vertex 5 is having the minimum cost. So you will select 5. Okay. From vertex 5 you have two direct paths to 4 and to vertex 6. So again using this formula you have to check whether 6 plus 2 is less than 9. Yes, it is less than 9, so you have to update the 9 by 8. Okay, and here 6 plus 5 is 11. 11 is less than infinity. Yes, so you have to update the value of V. So it is 11. Now again out of these two vertices, which vertex having the minimum cost? This 4, vertex 4 is having the minimum cost. So you will select this one. Okay, and then what you will do, you have to find the path from vertex 4 to other vertices. So here only one vertex is left and there is a direct path. So 8 plus 1 is 9 and 9 is less than 11. So again you have to update the value of cost value of 6 by 8 plus 1, 9. Okay, so this is how the relaxation process is going on. Now you have to draw a table and like this you have to find out. So suppose this is a table. This is a list of vertices. You have selected vertex 1 as the starting vertex and all other vertices remaining are 2, 3, 4, 5 and 6. So using Dijkstra's algorithm, what you found here? You found the shortest path from vertex 1 to vertex 2, then 3, then 4, then 5 and 6. So you have calculated the distances and that distances is indicated by D of V. Okay. So what was the D of V? D of 2 is 2. So you will write 2 here. Clear? You will write 2 here. What is D of V? D of 3? D of 3 is 3. D of 4 is 8. Okay. D of 5 is 6. Okay. D of 6 is 9. Clear? So these are the distances from vertex 1. So that means you have, now you just check, you have a direct path from 1 to 2 and 3 only. And 4 to 4 and 5, 6, you don't have direct paths from 1. Still you have minimum cost paths. That means you can reach vertex 4 by traveling a distance of 8. Initially what you found it as infinity, but later via 2 you can go to 4, isn't it? So that is how the process goes on. So you selected 1, then 2, then 3, then 5, then 4, then 6. At last you selected 6. Now, I will show you what is the drawback of this Dijkstra's algorithm. So, this Dijkstra algorithm will give you the single source shortest path for a directed as well as undirected graph. Now, let us see. We have another graph. Okay. So, I am removing this one. Clear? I am removing this graph. I am clearing all this thing. Okay. Okay. Now, what happens? I am drawing another graph. So this one, this is our graph, just to show you what is the drawback of a Dijkstra algorithm. If you are using Dijkstra algorithm to find the single source shortest path, then this will be your drawback. So take a small graph, you have only 4 vertices. And this is a directed graph, okay? So 1 to 2 you have an edge and is directed also, and from 1 to 4 you have a directed edge. From 3 to 2 you have a directed edge. Sorry. So 3 to 2 you have a directed edge, and from 4 to 3 you have a directed edge. Now you have to specify the cost on these edges. So let us specify, this is a weighted graph, so you have to specify the weight here. So here we have a negative weight, okay. Negative weight is also allowed on a graph, clear? But now let us see what is the drawback of Dijkstra's algorithm when you are using Dijkstra's approach for solving single source shortest path problem. Okay, so let us do the same thing. Now, suppose you are starting from 1. Okay, this is your S, your source vertex, S. Clear? Now what you have to do, you have to find the shortest path from 1 to 2 to 3 and to 4 also. Let us see. So here find the value. So since source vertex is 1, so the cost of 1 is 1, 0. Cost of 2 is 3. Why? Because you have a directed path from 1 to 2. Cost of 4 is 5. Okay. Why? Because you have a directed path from 1 to 4. That is 5. Okay. Now cost of 3. What is cost of 3 from 1 to 3? You don't have a directed path from 1 to 3. So initially it will be infinity. Now what is the next step? After finding the shortest cost of each vertex, you have to find the vertex which is having the minimum cost. So the minimum cost vertex is 2. Why? Because 3 is having the minimum value for vertex 2. Now you are going to select vertex 2. Initially you have already selected 1. Now you are selecting 2. Now from 2 you have to find the minimum cost path. So since from 2 you don't have any directed graph, you don't have to 1, and you don't have a directed path to 4 and for 3 also. So it remains like that. So no change will occur. Now you have to find the another vertex which is having the minimum value. So this vertex 4 is having the minimum value. It is having the cost 5. So you are selecting vertex 4. Now you have to find the shortest path from vertex 4 to other vertices remaining. So the remaining vertex is 3, and you have a directed path from 4 to 3. So you can do relaxation at 3. Why? Because the 3 is containing infinity value, and using the relaxation formula you will get 5 plus 2, 7 is less than infinity. So you have to change the cost of 3 by 7. You have to relax the value of cost of vertex 3 to 7. Now you are selecting this. Okay. Again, from vertex 3, you have to find the shortest path to other vertices. So you can see that from vertex 3, you have a directed path to vertex 2. Now what happens? Now when you see this, what happens? You see the value 7. What is a relaxation? So you have to follow that formula. 7 plus cost of 3 comma 2. So 3 comma 2 is minus 3. So 7 plus of minus 3, that means 7 minus 3 is 4. Okay, and it is a value of 3. So what happens? So it is not going. Suppose it is 13. Okay, let us have. So it is not going to do any change. Okay, it is not going to give any change right now. Now what happens is, suppose a value here was 13. This value was 13. Sorry. Suppose this value was 13. So what was the value will be here? That will be 13. Okay. Now check. 7 minus 3, it was 4. So 4 is less than 13. But you cannot relax the value of vertex 2. Why? Because we have already selected vertex 2. So you cannot modify the value of vertex 2 to 4. Even if you are getting the minimum value as 4, you cannot opt that. Okay, so that is the disadvantage of Dijkstra's algorithm. Clear? So the Dijkstra's algorithm is not valid for a graph which contains negative weights. Clear? So this much is about a single source shortest path using Dijkstra's algorithm. So hope this is clear to all of you. You please watch the video number of times to understand the concept. And if you have any doubt, you can contact me. Thank you. So thank you.